Okay, so we just did a quick review of trigonometry the other day, and now it's time to spice things up. And what makes things more exciting than basic right triangle trig? Well, it's word problems. So before we get into these word problems, let's define some terms that we're going to be using. And the first term I want you to define, and remember you have notes that go along with this, is the angle of elevation. And the angle of elevation is formed by your normal line of sight, so that's straight ahead, your normal line of sight, and your new elevated line of sight. So, you know, when you lift your head and you look up, you're pushing your line of sight up, and this angle right here, this is the Greek letter alpha. That is your angle of elevation. And then we have an angle of depression. And that's the exact same definition, except instead of saying the angle formed by the normal line of sight and the new elevated line of sight, it's the new depressed line of sight. So again, it's the idea that you want to be looking straight ahead, but instead you push that angle downwards. You depress it and you're looking down. So that is the angle of depression. And this is the one that most kids make a mistake with. They draw the angle of depression here, but it's not there. It's the normal line of sight being pushed down. So let's just jump in and work some problems. So here's your first problem. Now what I'm going to encourage you to do in this video, what I'm encouraging you to do is to pause it, draw a picture, and try to solve it. And then when you're done solving it, unpause the video and see how I did it and see if we match up there. That's the best way to do this. So go ahead, jump in and see what you can do. Well, hey, welcome back. So first of all, this is what I did. I drew a picture. I have a searchlight right here, and it's located 200 meters away from a weather office. And then what happens is somebody comes out of this weather office and they look up at an angle of elevation of 35 degrees. See right here, look up at an angle of elevation of 35 degrees, and they see where the light, the searchlight, hits the cloud ceiling. And that happens to form a right triangle. And what we're looking for in this right triangle is x, the height of the cloud ceiling. How high above the ground is the cloud ceiling? Well, golly, what we've got here is a perfect time to use the tangent function. We have an angle, we have the side opposite the angle, and we have the side adjacent or next to the angle. And that, of course, is the tangent function. So the tangent of 35 degrees equals the opposite over the adjacent. So in this case, the opposite of x and the adjacent, 200. So the very first thing I want to see is a picture. The second thing I need to see is your equation. What trig function are you using? What angle are you using? What ratio are you using? The third thing I want to see is what you're putting into your calculator. Now, you know, you all work this at different rates, but if we're trying to get x by itself, you multiply both sides by 200, and we get x equals 200 times the tangent of 35 degrees. And then the final thing that we get is we put that in our calculator, make sure you're in degrees mode, there's your answer, 140.042 meters. Okay, so that's the bare minimum I need to see. I want to see a picture. I want to see what your initial trig equation is. I want to see what you're going to type into your calculator, and I want to see your answer. So let's take a look at number 2. Again, this is a good time to pause, see what your picture looks like, try the problem, and come back. Pause as much as you need to. Just see if you can do it on your own. Okay, welcome back. So the first thing I did is I converted these degrees, minutes, and seconds into just pure degrees. And we learned how to do that in our guided lesson the other day, so you can reread that. Now, we're looking for two distances, a ground distance and a true distance. So first of all, the plane is 3 miles above the ground. There it is. We know that the angle of depression is 15 degrees, 37 minutes, 30 seconds, or 15.625 degrees. And that's the angle of depression. Now, what most kids do is they draw the line of sight from the airplane to the airport, and they put that angle there. But that would be wrong. That's not the angle of depression. Do you see how easy it is to make a mistake with angle of depression? The angle of depression comes from your normal line of sight, and that normal line of sight for us is right here. It goes from the airplane straight out, and we push it down. This is the 15 degrees, or 15.625 degrees, right there. That's where we want it to be. Now, we're looking for two things. First, we're looking for the ground distance, which I call x. That's the ground distance, the distance along the ground. So the triangle that I want to use in this particular case is this green triangle right here. Boom, 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 this one. That is a right triangle, because remember, height is always a right angle. So it's a right triangle. But I need to take this 15.6525 degrees, and I'm going to put it down here. And I can do that because in geometry, these are alternate interior angles. So I know since the lines are parallel, the alternate interior angles are congruent. Now, standing at this 15.625 degrees, I see that I have an opposite side and an adjacent side. So that is a tangent function. So somewhere here, I have the tangent of 15.625 degrees is the opposite over the adjacent. Now, you have to work your algebra magic to get the x by itself. So figure out how to get that x by itself and then come back to the video. Welcome back again. So to get the x by itself, you have to do a little bit of math here, but I did that in my head. It turns out that that's what x is. And some of you can do this in your head. And if you can, well, welcome to the Trigonometry Shortcut Club. You figured out a shortcut for taking this first equation and making it look like that. Once you have that, you can type that in your calculator and get x in, whoops, those should be wavy equals, because we are, after all, rounding. X is about equal to 10.727 miles. Now that is the ground distance. But we also want the true distance. And the true distance in this case is right along here. This y value, that's the true distance, because the airplane is allowed to travel through the air. So in this case, we're still going to use the green triangle, and we're going to stand at 16.25 degrees. But this time we have the opposite and the hypotenuse. And that, of course, is the sine function. So the sine of 15.625 degrees is the opposite over the hypotenuse. Oops, I guess I called that t for true distance. Let me cross out that y. T for true. So we have to get t by itself. If you're part of the shortcut club, awesome. You know that t equals 3 divided by the sine of 15.625. And that gives us our final answer here, whoops, of 11.138 miles. Okay? All right. So you have another problem to try on your own, and that's this one. Pause and give it a go. Welcome back. Here's my picture. I know that the angle of elevation is 40 degrees, and I know that right here we have this height x. Now remember that Olivia is not, her eyes aren't on the ground. She's 5 feet above. We'll worry about that 5 feet later. Right now, I'm just going to worry about this yellow triangle right here. And in that yellow triangle, I know that this distance right across here is 20 feet. So I use the tangent function. The tangent of 40 is opposite over adjacent, x over 20. I solve for x. I put that in my calculator. That's x. That's not the height of the tree. To find the height of the tree, I have to add on Olivia's eye height. So I add 5, and that gets me the tree height. Okay, so now we're moving on to number 4. And number 4, I want you to try the problem. I want you to draw a picture, write the equation. I want you to solve the equation and get me an answer. And when you come back, here it is. That's the answer you should get. Now, we have one last problem, and that's number 5. So in number 5, I want you to sketch this picture, and then we need to talk. So first of all, let's remember we're dealing with an angle of depression here. So there's my normal line of sight. Now we have to figure out who's closer to the base of the cliff. Is Camille closer or is Wesley closer? Well, the angle of depression to Camille is 25 degrees. So that pushes this normal line of sight down more than we're going to have to push it to get to Wesley. So Wesley's angle of depression is 18 degrees. That's not as severe of a push as Camille's is. So we have basically these two triangles. We have this one red triangle, which is right here. I will highlight that in this pink highlighter here, right here. And we have this bigger blue triangle. Oh, my color is terrible. Actually, that's not bad. It did go out of the lines. Yeah, okay, great. So let's just erase that. That's kind of just embarrassing. So there's the pink triangle that goes with Camille, and then we have the bigger triangle that goes with Wesley. But what I'm looking for is the distance between both people here. And I don't think I can find that directly. I'm going to have to find it indirectly. So the first thing I'm going to do is I'm going to say, well, okay, Wesley's distance from the base of the cliff to where he's standing is W. And notice how I took this 18 degrees and I moved it down there. Camille's distance to the base of the cliff, C, is right there. And again, for Camille, we happen to know that this angle right here is 25 degrees. Because, again, that geometry, these are alternate interior angles. So the distance between Wesley and Camille, I can't find directly. But look at what I can find. I can use the tangent function. Tangent of 25 is the opposite over the adjacent. And I can find Camille's distance here. Where is it? By taking 300 divided by the tangent of 25. And that tells me that Camille is about 643 feet from the bottom of the cliff. Now I can do the same for this giant blue triangle that's Wesley's. This giant blue triangle right here. And so for Wesley, I know that again, the tangent of 18 is the opposite over the adjacent. Now W is the distance Wesley is from the base of the cliff. And so Wesley is 300 divided by the tangent of 18. So his distance is about 923 feet from the base of the cliff. So knowing what W is and knowing what C is, we can now find this distance right here. And that's the, I have something happen there. That's the distance between Camille and Wesley. And so a little subtraction tells us they're 279.95 feet apart. And that is far enough apart for Ahmed to get down and stop Wesley from stealing the love of his life. Wasn't that a lovely story? And that's how we can use math in the real world. Think of the number of times you've been standing on a cliff and someone's trying to come in and rob the love of your life. With simple math and, of course, angle measuring tools like hypsometers and maybe a pocket calculator, you can do all this calculation and use math to save the day. And I hope this lesson was inspiring for you. I will see you tomorrow.